This tutorial concentrates on the last remaining collection type, dictionaries. Dictionaries are collections of key value pairs. In other words, we have a pair. Each pair contains a key and a value. These are paired up. They go together. There is no order in the way these pairs are placed within a dictionary. The values within the dictionary are all of the same type, and the keys are also all of the same type, but the type of the keys is not necessarily the same as the type of the values. They could be different. Declaring dictionaries can be done in a number of ways, similar to other declarations we've seen before. The syntax used is shown here. So if you're doing declaration alone, we can start with this long form of declaration where we are saying x1 is a variable of type dictionary, and the dictionary itself contains key value pairs where the key in this particular case is of type integer and the value is of type double. So each pair within the dictionary has a key and a value. The key is of type integer and the value is of type double. Here we do not do any assignment. A shorthand for this syntax is shown here. We use square brackets. Inside the square brackets, we first mention the type of the key followed by colon, and then the type of the value. So this is saying that our key type is integer and the type of our values is going to be double. Again, there is no assignment here. We could use the initializer format in a similar way that we've seen in the past in the case of other types, where in this example we are saying x3 is a variable of type dictionary where the key is of type integer and the value is of type double. So it is important again to notice that in all these declarations, the type is given by the dictionary of type integer and double. In this format, we declare and at the same time assign an empty dictionary to x3. There is no assignment up here, but here by default we assign an empty dictionary. And this is the shorthand version of the format shown above. Also note that in the case of declaration alone we use colon here, whereas in the case of in the cases where we're using initializers, we use the equal sign here. Like other data types, we could do simultaneous declaration and assignment of dictionaries. Again, I've divided the simultaneous declaration and assignment into two parts. First part is when we explicitly mention the name of the type, and the second one is the case that the Swift determines the type of our declared variable or constant by inference. Let's have a look at the explicit type first. Here we are saying that x4 is a variable. This might as well be a constant. I'm just showing here the declaration for variables, but the same could apply to constants. So x4 is a variable of type dictionary of int and double, and then we assign this value to x4. If you notice here, the entries here within the square brackets each have a pair. The first part of the pair is the key, followed by a colon, and the second part of the pair is the actual value. So this is the key value pair that we use in the dictionaries. The second entry again has a key which is equal to 3 followed by colon, and 10.5 is the value of the dictionary entry associated with that key. The shorthand for this is shown here. We could use this format, which resembles the actual entries of the dictionary here. So we can see the key type followed by colon. So this has a one-to-one relationship with the first entry of the pair, and this one is the type of the value for each key value pair, and this corresponds to the second entry in a pair, in this case 5.1 or 10.5. Now the case of inference correspond to these examples. We might think that similar to arrays and other data type we've seen before, we could use the initializer format to and write something like this, where we have the dictionary keyword followed by angled brackets, and inside we put the types of key and value pairs, and within brackets we mention the initialization value of the dictionary. This is not actually allowed in Swift, and if you enter this in Xcode, you will see that this will result in a runtime error. Similarly, we can't use the shorthand format like so. Again, we will see a runtime error if we use this. So the only way that we can use inference in connection with dictionaries is when we use a simultaneous declaration assignment following this format, where we say x3 is a variable whose value is given by this. Then Swift, by seeing this initialization value, realizes that okay, it's dealing with a dictionary, so x3 is of type dictionary, and then by looking at the types of the key value pairs, Swift realizes that the type of key, in this case integer, and the type of value is double. So from there it fully understands that the type of x3 is a dictionary whose key value is of type integer, and its the value of its key value pair is of type double. An empty dictionary is shown by this notation, square brackets, and within the square brackets we have a single colon. Here is an example of declaring a variable called x1, which is of type dictionary of int and double. That would be the types of its key value pairs. And then we're assigning an empty dictionary to our variable x1 here. Again, this could be a constant. I'm just showing variables as just an example. So for both variables and constants, we could use all the declaration and assignment cases that we've discussed so far. One thing I'd like to point out here is that please note that when we're using the square bracket format for dictionaries, we separate the key and value types by a colon. When we're using the angled brackets format, the separation is done by a comma, not a colon. After the declaration is completed, we could assign or reassign dictionaries to a variable or constant. Here I'm showing the case of assigning or reassigning this dictionary literal to x1. Okay, similar to arrays and sets, when we looked at some typical operations, here I'll be looking at some typical operations used in connection with dictionaries. We could use count, as in the case of arrays and sets, to count the number of pairs in each dictionary. So if we have a constant dictionary called x, whose value is given here, we could use the dot count so-called property of the dictionary to count the number of dictionary pairs. In this case, the answer is going to be 2 because we have 2 pairs here. Each pair contains a key which is of type character and a value which is of type string. So the return value of this x.count operation is assigned to our second constant y, which results in y to be equal to 2. We can also check whether a dictionary is empty or not. Here is an example where x is again a constant dictionary of type int, and it is set to be equal to an empty dictionary. Y is a constant, and we are assigning the value returned to it by x dot is empty, where is empty, like the other the cases of arrays and sets, determines whether x is empty or not. If it is indeed empty, it returns a boolean true to y here. Otherwise it would return a boolean false. In this particular example, of course, because x is empty, x dot is empty will be true and y will be equal to true. We can modify the entries of dictionaries using subscripts. The way it is done is shown by the example here, where x is a variable of type dictionary of int and double. So if we wish to change the value of the first key value pair from 9.1 to 60.1, this is how we do this. We start with the name of our variable, which is a dictionary, followed by square brackets. Within the square brackets, we use the key of the pair of interest, in this case 10. So we are saying here that change the value of the key value pair pointed at by key 10 to 60.1. So as a result of that, x will become equal to this, which is the same as that, but if you notice, the value of the first pair is now 60.1 instead of 9.1. We could extract the keys or the values of dictionaries. To do that, we use this keyword dot keys or dot values, and we put those in front of the name of variable. So x dot keys here extracts the keys of dictionary x, and x dot values down here extracts the values of dictionary x. Now we put those within parentheses like so, and before that we place square brackets, and within that we put the type of the keys of the dictionary of interest. So here the keys are of type integer, that's why we have integer here. What we see here is effectively the idea of casting. So whatever comes out of this, whatever is returned by this, is casted to become of type array of integers. So out of this we get a series of values, 10 and 20 in this case, and those values, by using this cast operation, is converted to an array of integers, and that array is returned and given to y, and the value y will become equal to that array, in this case 10, 20, which are the contents of the keys of this dictionary. Similarly, we can use casting. Inside the square brackets here we put the type of the values of the dictionary, in this case double. So what this does is x dot values will return a series of parameters which are equal to the values of the dictionary, in this case 9.1 and 5. Then applying casting here is those series of parameters will be converted to array of doubles. Note that the square brackets here are shown to indicate that the casting is going to include the conversion to array, and the double inside indicates that what is going to be the data type of the elements of that array. So this is going to be an array of doubles, and this is going to be an array of integers. We could also read as opposed to write the entries of a dictionary using subscripts. The way that can be done is very similar to the case of writing. So here we have a variable which is of type dictionary of int and double. If you want to read the value of the dictionary corresponding to key 10, we use this notation, x followed by square brackets, and within the square brackets we insert the key of interest. This would return the value of the key value pair, which is 9.1, and that is assigned to y. One thing to notice here is, similar to sets, it is possible that the key that we enter here, the key that we wish to access, does not actually exist. If that happens, this operation is still valid, but the return value is going to be nil. So similar to sets, what happens here is that the return value of our access is going to be of an optional type. The reason, again, is, if you remember, the optionals were used where a variable or a parameter may not have a value. So if we're not sure if a parameter contains a value or not, we use optionals. So this is exactly the same case. Swift is not sure that what we are using here actually points at an existing entry. So as a result, it uses an optional of type double, which is the type of the value of the key value pair, and returns that to y in this example. So this operation would return 9.1, which will be of type optional double. Notice the question mark. Now, to just emphasize what I just said, let's look at the case of an example where we try to actually access a value which has no valid key. Valid key, key 11 here is not a valid key, and this would return a nil. Again, if you remember, nil is something which is used in connection with optionals, and as Swift uses an optional as a return value for reading from dictionaries, so nil can be used here. So nil is returned and assigned to z. Again, because the return value is of an optional type, when we wish to access it, similar to any optional, we have to unwrap it. So if you're sure that key 10 refers to a valid entry in our dictionary, we can unwrap it using the exclamation point, as we did with all the optionals that we saw in earlier tutorials. So if we didn't use the exclamation point, this expression here would return with a runtime error. So we need to unwrap it because this value is an optional. So by using the exclamation point, x10 here will return 9.1, which is the unwrapped value of this entry, and is added to 2. So the result is going to be 11.1, which is assigned to w. Again, as we are dealing with optionals when we are trying to read from dictionaries. We could use the result, return value of that reading in optional binding, as we did in previous tutorials. So in this example, I'm dealing with a variable of type dictionary of int double, and then using the optional binding arrangement in an if statement. We say if let y is equal to x10, do something here. So what this does is looking at the value of x10, if it contains a value, that value is unwrapped and assigned to temporary variable y, and then y can be used in the body of the if statement as we wish. Alternatively, we can use the dictionary's property update value to alter the entries of a dictionary. So here we have x, which is a variable of type dictionary int double. Then we use this expression here to alter the contents of x. The way this should be read as is like this, that we'd like to update the value of dictionary x by this value 60.1, and the key of the dictionary pair of interest is given by this value here, which is in this example is 10. So as a result of this operation, x will be changed and the new value of x is given here, where the value of key value pair pointed at by key 10 is now 60.1 as opposed to 9.1. What this thing returns is the old value of the entry, and it's going to be of type double, because the entries, the values of the dictionary are of type double. The other thing to note is that because it is possible that the key that we are using here is not a valid key, what is returned by this is going to be an optional double. So as a result, the value which is returned and assigned to y will be equal to 9.1, and the type of y is going to be an optional double. To re-emphasize this optional property of the return value of this operation, I'm showing another example here where the key is not actually valid. Key 11 does not exist. So as a result of this, what is returned is nil, and the value of x remains as the value after this line of code. No change in there, but a nil is returned to our variable z here, and if you recall, nil was a value which was used in connection with optionals. So it sort of re-emphasizes that what is returned by this is an optional. Similar to the case of subscripts, we can use update value with optional binding. Here in our if statement, we are using x.update value, the expression that we used before, and if this thing does not return a nil, the non-nil value is first unwrapped and then assigned to temporary value parameter y, and that parameter can then be used within the body of the if statement. In addition to altering the entries of dictionaries, We can insert a new entry into the dictionary or remove an entry from the dictionary. Here I'm showing an example of the way we can enter a new entry into the dictionary. The way it's done is by using subscripts, and the syntax is shown here, where X is the name of a dictionary variable, and inside square brackets we enter a new key which has to be different to the existing keys of the dictionary. So the existing keys are 10 and 20 in this case, and this has to be different. We follow this by an equal sign, and the new value of the new key value pair is stated after the equal sign. So what this statement does is it creates a new entry in the dictionary whose key value is 31, and the value of the key value pair is 6.2. The outcome of this operation is shown here, where X is changed from what it used to be up here to its new value there, where a new entry with the new key and the new value is added here. Similarly, we could use subscripts to remove an entry from a dictionary. The syntax is shown by this example, where we follow the name of our dictionary variable by square brackets. Within the square brackets, we enter the key of the dictionary entry that we'd like to remove. Then the equal sign, and on the right hand side of the equal sign we put the word nil. What this does, it looks into the dictionary, finds the entry whose key is 10, and then removes it from the dictionary. So the outcome of this operation is shown here, where X, which used to have 2 values, is now reduced to a dictionary with only 1 entry. The first entry, which has the key 10, which is equal to this value, is now removed. Alternatively, we could use the dictionary's property remove value to remove an entry from a dictionary. In this example, we have again a dictionary variable called X of type int double. We use this syntax, the name of the variable followed by dot remove value, and inside parentheses we have the label for key followed by colon, and then we enter the key of the entry of the dictionary that we would like to remove. The outcome of this would be a new value for X, which is shown here, where we can see that the first entry of the dictionary has been removed. What this expression returns is the value of the dictionary that we are trying to remove, and in this case that value is going to be 9.1. The type of the return value is going to be the same as the type of the values of the dictionary, in this case double. As it is possible that the entry that we would like to remove does not actually exist, in other words, as it is possible that this key is invalid, the return value is going to be an optional type. So instead of just returning a simple double here, this expression returns an optional double. So whatever is returned here is passed on to y, which is our second variable here. Y is going to be 9.1, as I explained before, and the type of y is optional double. To re-emphasize this optional nature of the return value, I'm showing another example where I'm trying to remove an entry from the dictionary whose key is 15. But as 15 is not a valid key, what is returned by this is going to be nil. And as we know, nil is a value which is used in connection with optionals. So as a result of this, X remains intact as it was the result of the previous line of code, and W here, which is our third variable, will be assigned the value nil, and the type of W is again optional double. If we wish to remove all the entries of a dictionary, we can do that by using the dictionaries property remove all, and the example is shown here where X has 2 entries. Then by using X dot remove all followed by empty parentheses, all the entries of X will be removed, and what is left behind is an empty dictionary. So after this operation, X will be equal to an empty dictionary. Similar to arrays and sets, where we iterated through the entries of arrays and sets using a for in loop, we could do the same thing with the dictionaries. We could use for in loops to access either the keys of a dictionary or the values within a dictionary, or we could even access the entries of a dictionary in key value pair format. The first example that I'm showing here is that using the for in loop, we are accessing the keys of a dictionary variable called X, which is declared above, and those keys are accessed through this X dot keys, where dot keys is a dictionary's property. What is generated here is a series of values of keys, which are all the keys associated with this dictionary, and those keys are assigned to this temporary parameter called key and used within the body of the for in loop. Similarly, we could do the same thing, and this time instead of extracting the keys of the dictionary, we can actually extract the values using x.values. Again, dot values here is a dictionary's property. This, as a result of this, a sequence of values of the dictionary is generated, and individual values are assigned to this temporary parameter called value, which is used within the body of the loop. Finally, we could extract the contents of the dictionary as pairs. Here, a sequence of pairs are generated. Each pair is used to assign to these 2 parameters. The first parameter is called key, second value. These are both temporary parameters. So once for each pair which is extracted from X, the key value is assigned to this parameter, the first parameter key, and the second content of a pair, which is the value of the pair, is assigned to this second parameter value. And the values of these 2 parameters are then used within the body of the loop. This takes us to the end of our discussion on the last remaining Swift collection type, namely dictionaries.